For this number, we're going to be using this law right here. A to the power of m root n is equals to a to the power of m over n. Now, this looks like this right here, because, well, anything that seems like it doesn't have a power is actually to the power of 1. So in this case, the a is 2, the m is 1, and the n is 3. So I'm just going to rewrite this whole equation down here. 2 to the power of x is equals to 2 to the power of m over n, which is 1 over 3. Now we can just cancel the bases, and we're left with x is equals to 1 over 3. And we have our answer. Next number, 243 to the power of x is equals to 3 to the power of 2. Now let's just write down the powers of 3. 3, and then times 3, 9, and times 3, 87, times 3, 81, times 3, 243, times... Actually, let's just stop there. We already reached 243. Now, we can just see in which place 243 is. It's in the 1, 2, 3, 4, 5th place. So from that information, we know that 243 is 3 to the power of 5 on the 5th place. And there is to the power of x, so let's just write that. Now I'm going to rewrite the 3 to the power of 2. Now we have to use another law for this. A to the power of m to the power of n is actually a to the power of m times n. So we can apply that here. Wait, I'm gonna write it up here. In this case, it's the a is the 3, the m is the 5, and the n is the x. So 3 to the power of 5 times x, which is 5x. And this is equals to 3 over 3 to the power of 2. Now our bases are the same, so we can cross those out again. So 5x is equals to 2. Okay, since we want to make the x all alone, we're gonna divide, we're gonna move this 5 to the other side, and that will make it divide. So 2 divided by 5. And that's our final answer. Alright, moving on. I'm gonna rewrite the powers of 3 again. 27, 81. I'll just stop at 81. Alright. So this expression right here is already very simplified. So I'm just gonna copy that down here. 3 to the power of 2x minus 5. Okay, since you've probably noticed the pattern from A and B, when we want to solve for these type of equations, we always have to cancel the base. Look at this. Look at this part, and where is it? Look at this part. Yeah, we always have to cancel the base. So it should be the same for this one. We already have a base 3 right here. So we'll try to make this a base 3 too. And surprisingly, we can. 9 is 3 to the power of 2. It's in the 2nd place, so we're gonna rewrite that as 3 to the power of 2. Times square root of 27. 27 is on the 3rd place, so we can just rewrite that as 3 to the power of 3. Now, we use this law again. This. In this case, the 3 is the a, the 3 is the m, and the n is 2. There's a 2 here, it's just not written. So I'm gonna copy this down. 3 to the power of 2x minus 5 is equals to 3 to the power of 2 times. When we want to convert this, we just write it as 3 to the power of 3 over 2. Now we use another law. A to the power of m times a to the power of n is equals to a to the power of m plus n. In this case, the a is 3, the m is 2, and the n is 3 over 2. So I'm going to write it down here. 3 to the power of 2x minus 5 is equals to 3 to the power of 2 plus 3 over 2. 2 plus 3 over 2, that is 7 over 2. So I'm going to rewrite it as 3 to the power of 2x minus 5 equals to 3 to the power of 7 over 2. Now we cancel the bases, and we're left with 2x minus 5 is equals to 7 over 2. Okay, now you can either just move the 5 to the other side, or you can move this 2 here. Either way, you will still end up with the same answer. So yeah, I'll just move the 2 here. When we want to move the 2, it becomes multiplication, right? So I'm going to rewrite that as 2 times 2x minus 5 is equals to 7. And then we just do the rainbow thing. We just do the rainbow thing again. 2 times 2x. I'm going to rewrite that up here. 2 times 2x, that's 4x. And then 2 times negative 5 is negative 10. This is all still equal to 7. Negative 10, you move it to the other side, it becomes plus 10. 4x is equals to 7 plus 10, which is 17. And we haven't fully gotten rid of and we haven't fully got the x all alone. We still have this 4 right here. So when we want to move it to the other side, it becomes divide. X is equals to 17 divided by 4. 17 over 4. And this is our answer. Oh, we still have the, forgot. Wait, what? I remember a square root here. Okay, so there are actually 2 ways to solve this. I'm gonna write both of them. So, first method is to square both sides. Because there's a square root here. And you can actually just square both sides so that this and this cancels out. And yeah, we're just left with 2 to the power of x minus 3 is equals to 16 squared. Okay, since this is base 2, we want to make this base 2. So I'm going to write 2 to the power of x minus 3. Okay, wait, actually, let's write down the powers of 2. 2, 4, 8, 16, 32, and so on. Well, just stop there. So, as you can see, 16 is in the 4th place. So, from that information, we know that 16 is 2 to the power of 4. And this is all to the power of 2, so let's just write that down. Okay, we're met with this law again. We multiply 4 times 2, and that is 8. 2 to the power of 8. Our bases are the same. We can just cancel, and we're left with x minus 3 is equals to 8. We move this 3 to the other side, and it becomes plus. So our answer is 11, because 8 plus 3 is 11. And we're done. Now I'm going to explain the second method, which is, well, using this law, where you make the power into fraction. So, okay, this is square root, right? So there's an invisible 2 right here. So not only we want to make the power a fraction, we move this 2 to the denominator. So 2 to the power of x minus 3 over 2 is equals to 16 is 2 to the power of 4. And now we can cancel the bases, and we're left with x minus 3 over 2 is equals to 4. And we want to move this 2 to the other side. Divide, moving to the other side, makes it multiplication. So we're left with 4 times 2. And we're not done yet. We're going to move the 3 to the other side. It becomes plus, right? So 4 times 2, that is 8. 8 plus 3, that is 11. Same answer. And yeah, we're done with number 5.